Everyone to our seminar today. Most of you probably know me, but if not, I'm Penny Williams, co-lead of Program 5 in the Cobotics Centre, so the human robot workforce. And today our speaker is Dave Scerri. Dave is the CEO of Biarri Optimisation, which is a company focused on leveraging the power of mathematics to unlock efficiencies in scheduling, planning, and rostering. So we've invited Dave along today to talk to us because we know that a lot of the challenges that we've heard our industry partners talk about is not just the technological challenges, but the issues associated with scheduling and planning their workers across different tasks. So Dave has worked with some of Australia's largest companies across retail, energy, supply chain, healthcare, and Fortune 500 companies globally. And Biarri is a software that looks at optimizing the workforce. He's been with Biarri for 12 years, but the CEO since 2022, and previously worked in AI research and was a founder at a sports technology startup. He has a computer science degree from RMIT University, so he is well qualified to talk in this space and is going to give us some insights today. But before we start, Dave, I'd also like to just kick off today by acknowledging the Turrbal and Yugara as the First Nations owners of the lands on which QUT now stands, and I'm joining you from QUT today. And I'd like to pay respects to their elders, laws, customs, and creation spirits, and recognise that these lands have always been places of sharing knowledge and learning, as we are going to today. I'd also like to acknowledge that people are joining us today from different lands, and so I also pay respects to the First Nations owners of the places from which you join this webinar today. So with no further ado, Dave, are you happy to kick off?
Thanks very much, Penny. Happy to kick off. I'm dialing in from Melbourne on the lands of the Wurundjeri people of the Kulin Nation, and we have an office in Brisbane, but we also have an office in Melbourne, so I'm based down here in Melbourne. And thank you very much for having me today to talk to you about three different workforce planning and task allocation problems that we've solved over the last few years that I thought would be potentially useful to this audience. And if I can switch slides. So I'll just start with a quick overview. I'll try not to spend too long on it, but a quick overview of Biarri as a company and the types of work we do. And then I'll jump into those three different case studies. So we solve complex optimization problems for businesses, mostly sort of medium to large businesses. We build bespoke software for those businesses to solve their complex problems. And we do that in a sort of end-to-end way. So we really understand what their problem is. We use some really clever mathematics to solve that problem. And then we build usually an end-to-end system that allows them to interact with that in an ongoing way. We focus really heavily on complex, hard problems that are high value to our customers. That usually means either increasing their revenue that they can generate or reducing their costs. So it's got to have an impact on their bottom line. Sometimes that's a little bit complicated. Sometimes it's about reducing risk or increasing the likelihood of doing something, but usually it's about a really direct impact on their bottom line. And we really focus on spaces where there's a lot of complexity. Off-the-shelf solutions don't do the job, and often these problems are being solved by really clever people using very manual methods, and that's where there's room for optimization software to provide the greatest benefit. We do that by building what we've called the Biarri Workbench, which is a platform that encapsulates all the algorithms and all the engines that we've built over the years for different customers in different industries. and we reuse that as we build out for each customer. So we're not starting from scratch, even though we're building sort of feature-rich, bespoke software. We're leveraging what we've built in the past, which means it gets delivered for lower cost and much faster. We're about 15 years old as a company. We started in Australia with offices in Melbourne and Brisbane then. Effectively, the commercial model of Biarri I'll get to a little bit later, but we've grown from Biarri Optimisation, which does everything, to a number of different companies, some of which have since been acquired. At Biarri Optimisation, we are a team of about 40 people. We have software developers, we have mathematicians, we have a lot of operations researchers, and then we have a small but growing team of sort of data science, ML people. Broadly, we solve problems across any industry or any domain and across any complex problem type. There are lots of things we've done that don't fit into these three neat categories, but this is our best effort at sort of describing to the market the types of areas we do things in. I'm mostly going to talk to you today about this workforce and crewing piece, which is about efficient allocation of human resources to different tasks. We do a lot in the supply chain, logistics, production, scheduling space, everything from matching orders to production. We do work in the meat industry around efficiently mapping cattle or lamb to orders. We do a lot of route optimization and other types of sort of scheduling, machine scheduling or production scheduling, efficient use of tanks. We do cargo ship scheduling. So we do a whole range of things in the sort of production and scheduling space. And then we do some work in the more long-term capital and strategic planning space. Where should I put my distribution center? How should I set up my supply routes? How should I lay pipeline for an oil and gas project? So often those projects, you sort of solve them once and you've got your answer. We've just done some work on in mining on efficient moving of long walls as part of an underground mine project. So get an answer once and then you move on. But today I'm really going to focus on this workforce and crewing. I've got a couple of slides here just on some of the companies that we've worked with over the years. We've worked with lots of really big companies around the world. Some of the top 50 biggest companies in the world. We did some work for Google on their fiber network a while ago. Marathon Petroleum is the biggest independent petroleum company in the world, and we help them plan and schedule their biofuel production across the US and Europe. We've worked with lots of retail customers, aviation customers, health customers, and I'll talk to sort of three of those today. So just a little bit tangential, but because of our commercial model, we at Biarri Optimisation are focused on solving new problems and new complex high-value problems. When we do that really well for some customers and we decide to turn that into a product that can solve that problem for lots of customers within a market, we tend to spin that out as a separate company that can then be focused on just solving that one problem over and over again. It's a different marketing model, different sales model, and different product development model. So we've done that quite successfully a number of times. Biarri Networks is quite a large company focused on fiber optic network design that was acquired in 2022 by a big multinational. Render Networks helps with the rollout of networks in the field. Biarri Rail focuses on train scheduling, crew scheduling. Crew software is focused on mostly fly in, fly out worker rostering and scheduling problems in the energy sector. And then Kangatech is about injury management for elite athletes. So all of those companies have sort of come out of Biarri Optimisation over the years, and most of those problems started as a single problem for a customer that we solved really well and allowed us to expand. In the workforce planning, crewing, complex resource management space, we've done a lot of different projects. I'm going to talk to 3 today, but Swissport is one of them. Swissport are a global company that do ground handling services for airlines. We started with them when pre-acquisition, they were called Aerocare in Australia, and they manage all the major airports in Australia. We now do work with Swissport across Asia, in Japan and Korea, but also are now moving into North America and some of the biggest airports in the world to manage ground handling services, scheduling and rostering there. V Group are a shipping company with 40,000 crew on ships going around the world at all the time. That's a longer term rostering problem because those crew are on ships for 3 months or 6 months or 9 months or quite a long period, and then need to get back to their home country when it's time for a break. So that's an interesting problem in itself. Some of the energy companies, you have mobile camps, you have fly in, fly out. There's some intricacies there that make it a really interesting rostering problem. We've done lots in rail over the time, in long haul bulk rail, where you have drivers who may spend a shift, may do a split shift. So they may take a train out to a mine, spend the night at the mine, and then drive a train back the next day. They may drive a train halfway to the mine, get on another train and come back. There's a whole range of different ways you can really efficiently increase the time that a train driver spends doing what they're best at, driving trains. And then we do, I'll skip the supermarket, but we do a lot in health around hospital staff, highly paid employees, trying to make fair and equitable rosters. Some of them have really interesting requirements, especially at sort of regional and remote hospitals, around trying to attract staff with favourable rosters and things like that. Okay, I'm going to jump into the first of 3 case studies. So this is a project we've been working on for the last few years, or last 2 years, around in-home care, particularly in the aged care sector. So this was for a client, Australian Unity, big Australian company. They're the biggest provider of in-home care. Well, they were the second biggest. They've just acquired the biggest, so they are now clearly the biggest. And they provide care to aged care patients in their home for various reasons. So it can be anything from sort of domestic assistance, which may be helping with cleaning tasks or sort of other domestic assistance tasks, cleaning and helping people, through to really highly qualified nurse level appointments and allied health even appointments with clients, patients within their own home. And they do that with hundreds of care workers and thousands of clients across Australia. It's a really big problem, and it's a problem that's getting much, much bigger as we have an aging population, and we're trying to keep more and more people in their homes and service them. So this is a big industry-wide problem. The funding from the government, most of this is funded by the government, is limited. It's increasing, but it's limited, and being able to adequately service customers and doing that in a way that is fair to staff, allows them to retain staff, allows staff to have a good quality of life and have a good roster that they're happy with, that fits in around their availability and their flexibility, but also that is cost effective enough to allow these organizations to continue to operate. Because if they're not in it to make a big profit. Most of these companies are sort of not-for-profits or mutuals or church-based organizations. They're not in it to make a big profit, but if they are making a big loss, they can't continue. So it's really about how do they balance that client, employee happiness, and cost effectiveness at any time. Certainly, this is a problem that was solved long before we came to them. They have had lots and lots of rosters solving this using combination of existing systems and Excel, and they've done that reasonably well. People get care, it happens. Their costs are high. They have clients not getting the visits that they've requested, and that then means they have a high turnover of clients as they have to go to other organizations to get care. And they have a high turnover of staff before we start with them, because there's lots of inefficiencies in the rosters, lots of breaks of engagement, lots of unfair or undesirable rosters for staff. So we worked with them to really look at everything in the scheduling and rostering space, every visit they have, all the way through from building an initial master roster to changing that on a daily and weekly basis as new visits come up or people go on leave and things happen. At a really high level, this is just a picture of the demand, so the per hour, how many aged care patients there are in their homes needing a visit at that time of day. And some of these are really flexible. You can be there any time between 8 a.m. and 6 p.m. Doesn't quite show up on this graph. Other things are, we sort of need someone there from 7:30 till 8 a.m. as they need to shower at that time, and it's quite fixed. So there's a big variance between really, really flexible work and really fixed work. But what this graph really goes to show is the availability of care workers outstrips the need for clients at every point of the day. And in theory, that makes it quite a simple problem. And even while this is there, Australian Uni were in a position where lots of these visits weren't able to happen. And the key reason for that really is the distribution of that demand. So all of these different things need to happen in different locations, some of them at the same time, and you need to be able to travel between them. So even though there's enough staff in theory at any one point in time, a lot of them are going to be traveling, a lot of them are going to be waiting for an appointment window to open, and that adds a lot of inefficiency, which means then you have a lot of visits not being able to happen, and a lot of other issues, high costs. So this is just an example of a care worker who in this case is a walker care worker. They don't drive. Lots of them do drive, but in inner Sydney, there are care workers who will start at their home address. They will go to a location and do a visit there. Then they'll go to another one. Then they'll go to another one throughout their day. Doing this efficiently and reducing obviously the amount they have to walk, the amount they have to wait between the time that the appointment is available. That is where all the efficiency comes from. So deciding whether this visit number one should be done by this care worker, or it should be done by another care worker who lives nearby, or it should be done by a care worker who drives here from another location, is a very complex problem. So this works by simultaneously generating both a schedule, which is a shift for each and every one of the care workers. So within that shift, you're going to travel to location A, you're going to do this visit, then you're going to travel to location B and do that visit. Then you're going to have your 30-minute lunch break, and then you're going to visit location C and then location D. And then you're going to head back to your home location. The next day, you're going to start at 10 a.m. instead of 9 a.m. and you're going to do this, and it's all going to fit in within your roster. We're going to give you a 28-day roster that tells you what shifts you're going to work. That means you don't work overtime. There are limits on how much you can work in a day and how much you can work in a week and how much you can work in a fortnight. So making sure that you've got sufficient gaps between your shifts, but that within your shift, everything is compliant with the employee agreements and SHAD's award, the relevant award. So we do this all as one big problem that we solve simultaneously. It's not, we're deciding which care worker does what and what that care worker's roster looks like. And we do that with a huge number of both hard constraints about the windows that things are, the time windows that things are available, the location of them, etc. Over time, all the hard constraints that come from the award, but a lot of soft constraints and costs. So we're trying to make sure that if there is a client who has 5 visits in a week, that we minimize the number of different care workers that come to them on different days. That's not always possible to make sure it's always the same person, especially if you have 10 visits a week or 20 visits a week. But we try to minimize the number of new faces that they see. We want to minimize undesirable shifts. So that can be things like overqualified workers doing underqualified work. It can be about lots of waiting. It can be lots of travel. It can be too short shifts. It can be shifts which have break of engagement, which is where they go away and get paid an allowance, but they don't get paid for that period. So all of those things we're trying to minimize. We're trying to minimize the cost to Australian Unity. So we do that really well, and we give them a complete schedule that they are able to follow. And down the bottom right corner, you can see increase in the number of visits that were delivered as planned has gone up from 60% before we put this system in up to 90%. So there's always things that happen on the day. There's bad traffic, there's visits that take longer, and things change. But in the vast majority of cases, the schedule is able to be followed. That gives the employee a lot of certainty. It gives the client a lot of certainty, and that really helps. But at the same time, we've shown really significant reductions in the cost of service, the amount of travel that the care workers are doing, and an increase in both the client and the employee satisfaction. So we're sort of without having to give up anything, just through better optimization and using some of that complexity and diving into it, we're able to come up with a solution that is sort of objectively better in every way than another solution, which is really promising. This is rolled out to most of their branches within Australia now, and they're seeing those benefits come to realization. There's a separate piece to this problem that makes it a little bit difficult, which is, so this is really talking about the longer term planning. How do I come up with a roster and schedule that allows us, where we're allowed to change anything, and we come up with an optimal schedule. What then happens is we add in new visits, and we have care workers who are unavailable or on leave, and we then need to make the minimum set of changes possible to keep everything else the same. So clients don't want suddenly to change the time of their visit, or employees don't want to have to work drastically different shifts because we've made that change. So it becomes almost a different problem about how you can make the minimal set of changes to do that. I'm running behind on time, so I'm going to jump through these last two a little bit more quickly so I can take any questions at the end, but we'll see how we go. So Swissport, ground handling services for lots of airports around the world. they, because they don't actually, they service the airlines rather than these employees working directly for the airlines. You can have employees from Swissport who will put on a Virgin outfit and do check-in for Virgin, and then they may switch and do a Jetstar flight in the afternoon. So they work across airlines, and it means that they can be much more efficient than the airlines themselves in a lot of cases. That's effectively their business model, because they can have the same people do the same things. It's an interesting problem because you have the flight schedule really tightly dictates when these tasks have to happen. And you have a lot of complexity in that people will do a lot of different tasks within a single shift. So everything from the ramp people who are doing refueling, putting bags on planes, taking bags off planes, cleaning planes, doing the water and waste, doing those things, through to check-in desk, gate agent, the people who sort of escort you onto the plane and tell you to go down the ramp or out the back to the stairs. So all of those different roles, and they'll do different tasks within a single shift. Just give you a bit of a look at the tool that we use there. So this is a flight schedule up the top. Those flights, a plane coming into land and then a plane departing. You can see, I don't know if you can see my cursor, but that's what we call a turn, where a plane will be on the ground for some period and then leave. You have some departures, and the check-in desk is the shaded area. Check-in is open for those periods, so we need to man the check-in desk. We have some arrivals. We have different airlines here that we're doing it. And what that does is then spits out a huge number of tasks that need to happen based on that flight schedule. So there's check-in that needs to happen at different terminals. There are gate agent tasks that need to happen. None of the ramp stuff is here, but it spits out all of those tasks that really have to happen for the most part at very specific times based on when the plane is scheduled to depart or leave. There are some things that we can move in time. So when there is a turn, when a plane is on the ground for some period, there are cleaning tasks, refueling tasks, some of those things that just have to happen at some point while the plane is on the ground. And you can do that. If it's more efficient, you can do that as soon as it touches down, or you can do it just before it leaves, depending on what makes sense from the rest of your schedule. So what we do is we turn all of those tasks then into shifts. You can see each of these rows is a shift with a series of tasks. This doesn't look particularly efficient. You can see lots of big gaps there where there's no work for people to do. And that does happen sometimes in this, because you have this, if you look at sort of 6 a.m., you have a huge number of simultaneous tasks. You have a lot of flights leaving at the same time, and you need people to be on all of those different gates at the same time. Even the travel time between this task on row 50 and this task on row 56, even if they didn't quite overlap, you would still sort of need to have those two people there. And then you've got a similar thing happening a bit later in the day, where you need that number of simultaneous people. So it's better than doing these really short shifts that, depending on the minimum shift length and employee agreements, it's often better to keep people on and have these big gaps in the middle of the day. But often we can do this really efficiently. If you try to do this manually by hand, you introduce a lot of inefficiency because it's a complex problem. We then take those shifts, and each of these shifts can mostly be done by quite a range of different people. So unlike the in-home care, where it's really focused on what that shift looks like, the shift would look different if it was done by someone else, because they'd be starting from a different location, they'd be ending at a different location, they may have different qualifications. For the most part here, we have people with fairly similar qualifications, and they all start at the same thing. Lots of them are sort of full-time or follow fixed rosters, or then there's a lot of casuals and other people. So there's pools of people that are fairly similar, and we understand when we're generating these shifts that we can generate them in a way that they will be able to be covered by a large number of people. So then we move to the working out which shift is done by which person. And we do that looking over a 14 or 28-day period, making sure that their target hours for that person are met, that they get their 2 days off in between, that any annual leave or anything else that's there, that they don't end up doing too many undesirable shifts, that they're qualified for everything that they do within the shift. And here's just a testimonial from Peter at Swissport, which it used to take them sort of 2 to 3 days to do this. It now takes them 15 minutes to generate it. And what that has sort of allowed them to do is often do a whole lot more sort of scenario planning, and they know that they can generate a larger number of solutions. They can change rules, they can think about employee bargaining, they can think about different things and really quickly get very high quality solutions, optimal solutions out of the software. That in Perth, it used to be that they would solve for a whole month, and that would take them 8 days. It now takes them 15 minutes. So it's just had a really huge impact. They've been able to grow as Aerocare. They're able to grow their planning team from doing 4 airports to 45 airports without having to actually increase the number of planners, just by using software instead. Okay, third case study, again, is a bit different. This is a distribution center for a large supermarket. So it's about, you have large volumes coming in from the suppliers of their product into the distribution center, and that needs to be sorted and put in the right place. And then you have orders going out to the stores that need to be picked based on what the order from the store is. They put them into cages, where those cages are then aligned with the aisles of the supermarket, so it's much easier for the employees in the store to unload it. But effectively, for a lot of this stuff, it's really flexible in time. So you need to have done enough volume by the time you know that you need to have done those cages for that store by the time that pickup is scheduled at 2 p.m. But you can do it at 8 a.m. if you want, as long as you don't violate other constraints. So lots of flexibility, lots of volume. These are just sort of across days, but across different areas. You've got your ambient, your frozen, your fresh, all these different parts of the business that need these tasks happen. And you have some number of cases that you need to do. We don't go down to the sort of minute task level that you're going to be packing this cage for this store. Instead, we're saying we know we need to have this amount of volume done in these periods in order to meet those demands. And we can do them at different rates and different levels of productivity. One of the big parts of that, I'll just jump to, no, I don't have it, is that different employees, they know different employees will have different productivity rates, and they capture that well and they understand that well. People who have been there for a long time and understand where things are and what they're doing will be able to pick cases at a much higher rate than an agency staff who's brought in for the night to help meet demand. So they have to factor that in. It factors into the cost of delivery, but in order to make sure that they don't overstaff or understaff and not be able to hit their volume targets. So that is a big part of this, is how do you choose the right people to be on the right shifts in order to meet the volume at different points in time. There are limitations around what equipment they can use at different times. You've only got certain amounts of different equipment, so you can't be asking people to, you can't leave all your demand for 1 3-hour period and have all your staff come in then and try and get it all done, because you won't have either the space in the to put things for the stores to collect them, or the incoming stuff needs to be cleared out before then. So you need to spread it out as much as you can, but you also need to meet these sometimes really peaky demands where everything needs to go out at the same time. So we generate a roster that says what people will be doing when. We have to do that with respect to load management as well. So making sure that employees don't work on hard tasks for long periods. We obviously can capture all of that. We know their productivity rate. We know how much they're going to be doing, and we know what we're scheduling for them over a shift and over a week or a fortnight. And so we can make sure that we carefully manage their fatigue with everything that they're doing. So I'm almost at time for questions, but I just wanted to, if there's one takeaway from this, it's really this slide, which sort of just says, for each of these problems, even though they are all sort of nominally solving the same problem, which is how do we efficiently allocate our employees to shifts in a roster, and what tasks should they do while they're in on that shift. Each of these has some really unique characteristics that mean that the way we solve the problem is really unique. And that's why we say that this sort of bespoke way of solving these problems and deeply understanding the problem and building a solution that's fit for purpose is really important. There's a different solution that we have when you have 40,000 ship crew versus when you have 500 distribution center employees with volume-based things and 30-minute granularity, but a 24/7 operation. So you have to care about fatigue overnight and fatigue levels, and making sure you have sufficient gaps. In aviation, we've got these really fixed in time tasks for the most part. We have employees though who can do almost any shift aside from sort of leadership shifts, but we've got a lot of flexibility there. But then we go down to, does it take you 4 minutes or 6 minutes to walk from gate 4 to gate 8? So really granular. But at the same time, they close down. Currently, we're just working on this for North America where they run 24/7, but they close down for 3 hours. And that means we can plan things one day at a time, and we really reset for the next day and start again. So we do that in a 2-stage process. In-home care, geographically diverse, really flexible with lots of the tasks. So you've got to decide when is the optimal time to do each task. Some really tight compatibility between care workers and clients in lots of cases. So you have less flexibility in that sometimes. It's mostly daytime. They do overnight shifts, but for the most part, it's sort of a day-based system and then a fortnight or monthly based roster. So we have to do that one all simultaneously. So really different under the hood, really different solutions and different complexity that comes out of each of these problems. I won't talk for any longer. I'll let with 6 minutes to go, I'll let anyone ask any questions that they may have if anything came out of it.
Thanks so much, Dave. We do actually have a question in the Q&A, so other people feel free to put your questions in there too. And this question says, thank you, first of all. Thank you so much for the presentation. Biarri seems to be targeting medium to large companies. I would like to know if the solutions offered by Biarri are feasible to small companies as well, or do you see any challenges in small companies adopting the solutions that Biarri offers?
Yeah, it's a good question. Certainly I mean, they're a very simple rostering problem. So if you have a cafe and you know that you need 3 staff at the morning coffee rush and you have 3 staff in the afternoon, you can do that manually and by hand, and you can do it really well. And if you use a very complex optimization engine, we're probably not going to come up with a better solution than what you can do manually or what sort of off-the-shelf rostering solutions will be able to do for you, particularly with that uncertainty of demand and other things where you need a buffer anyway. So it is often really about the reason we target medium and large businesses is because they have the complexity where manual in your head, pen and paper, Excel starts to fall over and you leave a lot of efficiency on the table. If there are small businesses where they have lots of employees, lots of moving parts, then absolutely it's still applicable. They'll still get the value out of it.
Okay, great. So do you find that there's a kind of a critical mass? Is it like, 300, 500 employees or much larger? I'm just thinking a lot of our industry partners are manufacturers with, certainly some complex problems in terms of, a lot of the issues that were discussed in terms of distribution and managing the workflow and production times and the staff needs, but they typically have smaller numbers of staff than what you're talking about there.
Yeah. So, I mean, pure staff numbers is not the only factor. Although if you've got one staff, it's never going to be complex. It's about thinking about how many total decisions you're making and how many options each of those decisions have. So it may be that you have 20 staff, but there are hundreds of tasks associated with each staff, and there are different locations that those tasks could be done, or there are different, out of a really large set of tasks that they could possibly do, they have to choose the best set of tasks to do. There may be lots of flexibility around shift times or other things. So it's about thinking about all of those different decisions. Now, it may be that when they're solving it manually, that they are reducing that down artificially. So they're saying, well, let's first decide what shifts people are going to do. And then now that we've fixed that in place, we've only got a very limited number of tasks that they could possibly do because we've already decided that they're starting at 8 a.m. and working at this bay. So you sort of have to really think about what is the total flexibility, what is the total number of possible decisions here. And when that number gets really big and scary from a trying to fit it in your head point of view, that's where the optimization software really proves its benefit.
Okay, great. Now, we have 2 more questions and 2 minutes to answer them in. So the first is from Will. So this is a technical question, so correct me if I get this wrong, Will. How much has the balance changed between using deterministic mathematics versus stochastic ML AI over the last decade?
Very good question. We have a data science ML capability in-house, and we're building that out. And it's interesting having people from that background and from an operations research background working together. OR being much more deterministic and ML being much more stochastic. And I can take 2 people to a sales meeting for a potential customer, and the ML data science people will see all of the uncertainty as the key problem, and they effectively are saying, if we can work out what's going to happen, then working out what to do becomes trivial because you know what's going to happen, so then you just come up with a schedule or plan to deal with that. And the operations research person looking at the same problem from a different direction will say, we'll just ignore the uncertainty, we'll just make some assumptions around what's going to happen. The real complexity is how can we come up with a schedule that then efficiently does the right thing based on what is going to happen. And obviously the correct answer is somewhere in the middle. You have to take into account some of that uncertainty and make better predictions, because the better predictions help you make better plans and better schedules. But it's certainly not the end goal. You can't just have better predictions and better understanding. There are a lot of problems that we face where that uncertainty is so significant and the predictive power is so poor that it is okay to make some assumptions. The cafe example, we don't know exactly how many people are going to be in, but we know we need 2 baristas working for that 3-hour period. And yes, some days there'll be almost none, and some days, but we just can't predict that well enough. So we just have to assume that we need 2 for that period based on history.
Okay, so we are at time. So I appreciate some people may need to leave, but there's one last question from Stina that if you've got a few minutes, Dave, to answer. So Stina says, thank you for the great presentation. I can certainly see how this is very useful across multiple industries and how there could be several benefits for employees as well. You mentioned an increase in employee satisfaction briefly. So how are employee perspectives being used in the development of the parameters of the system?
Yeah, it is a good question. And I think we talked about this a couple of weeks ago, Penny. Um, it, it's often done by talking to the planners and rosterers. So we know, or the planners and rosterers know that if they want retention of staff, that they need to do things in a way that is fair and reasonable, and that if they have too many undesirable or things that go against employee preferences, they will lose staff and that will make their job harder. So they are often, and different businesses are at different levels based on the market and other things, but they're often putting that as their number one concern. There are examples where we can come up with a schedule that reduces overtime. And the response we sort of get back from the planners is, well, if we cut overtime, everyone will leave because they want to get that overtime payment and they want to work those extra hours. So if you did things more efficiently and they finish their shift on time, they'd miss the overtime payment. They'll go somewhere else where they can get overtime pay. We do an interesting problem for a regional hospital that guarantees that if doctors who are in a couple move out to this regional hospital and work at the hospital, they guarantee that they'll both work the same days and the same nights, which means they can then spend their time off together. They probably don't know a whole lot of people in the town initially, so they get to at least do those things together. But they also say that they're not going to work alongside each other all day and all night. They'll work in different parts of the department at those times. So some of that is really focused on, it makes the problem a lot more complex, but it's purely focused on, if we don't make these employees happy, we're not going to be able to retain them. We're not going to be able to recruit people to come out and work at our hospitals.
All right, well, Dave, thank you for a really interesting presentation. We've got some great questions there. And if anybody wants to know more, your contact details are on the screen. Is it all right for people to contact you?
Absolutely. Yep. Send me an email or reach out, and happy to have a chat with anyone.
All right. Thank you so much, everyone. We'll leave it there.
Thanks very much.
Bye.